Okay, students, now we'll see the importance of that frequency analysis and everything you can easily understand. Okay, the spectrum. Okay, what is the meaning of spectrum? Spectrum is nothing but frequency domain. Okay, the frequency ranges now of a present in a signal is called as a bandwidth, and you know how to calculate the bandwidth and all these things. So now let us see now a simple communication system as we will see. What is a simple communication system? Okay, very simple communication system I want to explain to you. Now see here in the just we'll take the class itself. Okay, now I am the source of the information, I am transmitting the information. Okay, I am transmitting the information, therefore now this is nothing but transmitter or a source of information, right? This is the transmitter or a source of information. Now whatever the information I am transmitting, that information is passing through a medium. That information is passing through a medium. This is called as communication channel. Communication channel, or we call it as a transmission medium. We call it as transmission medium. Communication channel or transmission medium. This is the communication channel or transmission medium, and this communication channel or transmission medium, and next it is that information is received by you. Now you are all receiving the information, and this is the end point. Now this is the destination, right? Now this is the simple communication system, transmitter. Now most of the students are asking that whenever I just give the transmitter portion, and immediately you are saying that receiver. No. Now once if it is first designing part is transmitter. Once the transmitter portion is completed, you are concentrated which type of communication channel we are using and what should be the transmission medium which we are using for transmitting this signal. Now the third one and the last one is designing of the receiver. Okay, now don't do like this. Transmitter portion is completed, don't concentrate on the receiver portion. Wrong. Once the transmitter portion is completed, now what should be the transmitted signal and how that signal is transmitting through a communication channel or a transmission medium, what type of communication channel or transmission medium is available. Okay, now this is the simple communication system. This is the simple block diagram of a communication system. This is a simple block diagram of a communication system. We just concentrate on this particular system. Now this is the communication channel. Now here this communication channel or transmission medium, here I just divide into two parts. Now this communication channel or transmission medium, if this communication channel or transmission medium is a free space, or air, this is a free space. Now this is the communication channel or a free space medium as a free space or air. Now this is called as a wireless communication system, because this is a free space or air is used as a transmission medium. It is a wireless communication system, right? Now this is called as unguided medium, right? Now this is a wired. Now this is a unguided medium, or we call it as a wireless or unguided medium. Now this is wired medium, wired or guided medium. Now here twisted pair cable means a old BSNL cable, twisted pair cable, and your dish cable, coaxial cable, and nowadays most of the times we use the word optical fiber cable, fiber optic cable. Now these are the wired, okay. Now these are the guided mediums and these are the unguided medium, okay. This is the unguided medium or a wireless medium. Now these are the wired medium. What is this? All these are the transmission channels or a transmission medium or a communication channels. Let us take for example, now this is 0 hertz to 500 kilohertz. Now this is 0 to in terms of 500 megahertz. Now this is thousands of gigahertz to thousands of terahertz. Now this is nothing but 0 to infinity. What is this? What is all these things? Now see here, this is also the frequency ranges. See, this is also the frequency ranges. This is also the frequency range. This is also the frequency range. This is also frequency range. But these are the frequency ranges occupied by the channel. Now these are the frequency ranges occupied by the medium. This is called as channel bandwidth. The range of frequencies that the channel can transmit without distortion is called as channel bandwidth. Now from all this, one important point is nothing but channel bandwidth. What is this? Channel bandwidth. The range of frequencies. What is channel bandwidth? Signal bandwidth. There are two bandwidths in our communication system. One is signal bandwidth. Now the range of frequencies that the signal can occupy, the frequency ranges that the signal can occupy is called as signal bandwidth. Now the range of frequencies that the channel can transmit without any distortion is called as channel bandwidth. All these are the channel bandwidth. Now earlier the first class, what are the different kinds of practical signals which we are covered. Now those are the signal bandwidth. Understand not? Now this is the channel bandwidth and that one is the signal bandwidth. Now this is the way you design a simple communication system or any communication system. First transmitter, now transmission portion, next what should be the medium and what should be the communication channel. Now which channel is suitable, which medium is suitable, now which bandwidth is suitable to transmit the signal, and lastly you think about the receiver portion. Okay, this is a simple block diagram of a communication system. Okay, no doubt. Now we'll see the generalized block diagram of a communication system. Any communication system will try to concentrate. Okay. Now see here. Now concentrated. Okay. Now this is a voice signal. Okay. Whatever the signal I am just speaking out is a voice signal or a speech signal. Now my voice signal, my speech signal is able to transmit only this much of a class distance. Okay. So you go to after just 1 kilometer beyond me. Okay. Now I am speaking like this. Can you hear my voice signal after 1 kilometer? Not on a 1 kilometer. You just go to the ground floor. Can you hear my voice signal? No. Now why? Because my voice signal is a low frequency information signal which cannot able to transmit for longer distance. Am I not? My voice signal, which is a low frequency information signal which cannot transmit it for longer distance. Therefore now you see here, now I can write like this. This is the voice signal, voice information which is low frequency in nature, now which cannot transmit for the long distance. Now this is a non-electrical variation. Am I right or not? This is a non-electrical variation. If you want to speak to your friend, right? Now you are at Hyderabad and your friend is at Delhi. Okay. So if you want to speak to your friend, so can you say loudly? No. So you take a communication system. Am I right or not? You take a mobile. Now, sir, in that mobile, now there is no battery. So in the mobile, then there is no charging, there is no mobile. So it's working? No. So that mobile is responsible for electrical variation. Now let us take this is a mobile. Now you are giving input as a voice signal. Now this is a voice signal which is a low frequency information which is a non-electrical variation. But this electronic device is completely responsible for electrical variation. So now first what we have to do it is, now this is a non-electrical variation first it will be converted to electrical variation. Am I right? Not? So this non-electrical signal, first it will convert it to electrical variation. Now therefore the first block is a transducer. Now what is this? Now this is the transducer which is converting a non-electrical variation will be converted to electrical variation. Means what? Now this is the voice information as it is. This is the voice information. This is low frequency in nature, but this is the electrical variation. Okay. Now this is the voice information. Now see here. This is the voice information, low frequency in nature, non-electrical variation. So this is the transducer, a microphone or whatever it may be, mic, converting a non-electrical variations to electrical variation. That's what I'm saying. Electrical variation means it may be a voltage variation or it may be a current variation. So even this non-electrical signal is converted to electrical signal but cannot able to transmit for longer distance because this is a low frequency information signal. The problem of this signal itself is a low frequency information. So what should we do? We want to take the help of this is the modulator. See, you are the low frequency information. You cannot able to cross the bridge. The bridge is the distance between the transmitter and receiver. Then you take the help of the another person who can able to cross the bridge. Who can able to cross the bridge, right, safely. So, but the intention is not that particular person. The intention is this particular person is walk on the bridge, but you cannot. So you can take a help of any other person. Am I right? Not? So now that another person is nothing but this is a modulator. Now this is a oscillator. Let us assume this is an oscillator. Now this oscillator will generate a frequency. Now you generate a high frequency signal. Now this oscillator will generating a high frequency signal. Now see here, this is the high frequency signal. Now this high frequency signal will safely carry the low frequency information. Okay, most of the students are thinking that the modulator or a modulation is nothing but low frequency is gone, high frequency is coming. No, the modulation is the process of converting a low frequency information is into a high frequency. Now let us take for example, this is the low frequency information. Now this region is shifted to as it is at a high frequency. Okay, this is the what the process of modulation. Now modulation is nothing but low frequency is gone, high frequency is only available. No, the modulation is a process of as it is the original information now which is transformed to a high frequency boundary. Okay, so I just see with the diagram also. Okay, with the mathematical we will see the equations in time domain, frequency domains also. So this is the, so can I take this is low frequency. I can write the words clearly. You just see here, low frequency voice information. Now this is the low frequency voice information which is available at, this is the low frequency voice information which is available at high frequency. This is which nature? Electrical variation. This is the electrical variation. Now see here, this is the, now I just give a few names for this. Now this low frequency information now which is available at high frequency. Okay, now this high frequency will safely, this high frequency signal will safely carry the low frequency information. Therefore this high frequency signal is called as carrier signal. This high frequency signal which is called as carrier signal. This is the carrier signal will safely carry the low frequency information. Now this is the voice information, low frequency in nature. Now this is the high frequency signal which is safely carries information. Therefore, this is called as carrier signal. Now, this modulation signal is transmitting through a communication channel or transmission medium. This is the communication channel or transmission medium. This is the communication channel or transmission medium. This is the communication channel or transmission medium. Now this communication channel or transmission medium, now this is the transmitted signal. This portion is the transmission portion, right? Now this is the transmitter. Now it's transmitting through the channel. Now what happened now? You here one more point also you want to identify. Now this channel bandwidth should be more than this transmitted signal bandwidth. Am I not? This channel bandwidth should be more than this transmitted bandwidth. Then only this signal is transmitting to the channel, right? So now you just see here what is the input to the receiver or what is out of the communication channel. Now, because of so many losses, okay, due to dispersion or scattering, attenuation, absorption, now whatever the signal you are transmitting, now that signal strength maybe decreases, okay. So, now that decreased signal strength should be increased by using repeaters, right. Now, what is the job of the repeaters? Now, these repeaters are receiving the weak signal strength and regenerating, re-amplifying and retransmitting. That's why this is called as repeater. Then whatever the signal finally. So this is the low frequency voice information. This is the low frequency voice information which is available at high frequency. Now this is which nature? Electrical variation, electrical nature. Now this electrical signal, right, so is crossing the bridge. The bridge is nothing but the distance between the transmitter and receiver. Yes, it is safely crossed the bridge. Then is there any use of the high frequency signal? No, the important information is nothing but a low frequency. Therefore, now this is the process of taking the help of high frequency. Now the high frequency's job is completed, then remove the high frequency. Exactly the process of modulation is nothing but the demodulation. This is the demodulator. Now this is the demodulator. Whatever the frequency which we are using, the same high frequency signal, now you are remove high frequency signal. Now here you just take the help of the high frequency. Now here you just remove the high frequency signal. Now this is the high frequency signal, or this is called as carrier signal. Now after demodulation, now this is the high frequency signal is removed. Then this is the low frequency voice information. Now this is the voice information which is low frequency. Which variation? Electrical variation. Now electrical variation. But you cannot able to understand that signal because that is electrical variation. Now again you take the help of transducer. Now if you take the help of transducer or a loudspeaker, right? Now this is for example loudspeaker. Now that is example mic. Okay. Now if you see here, now this transducer, what the transducer is doing now? Now this transducer, now this is the voice information. This is low frequency nature. Now this is the non-electrical variation. Now this is the loudspeaker. Now this is the microphone, mic. Now this is the generalized block diagram of a communication system. Any communication system, any distance. Only the difference is if the distance between transmitter and receiver is very long, then you use generating this high frequency carrier signal in terms of megahertz, gigahertz like this in order to cover the distance. Okay, and that is one point. And another point is how much frequency you are using here. The same frequency you are demodulation the process. And repeater, what is repeater? Due to dispersion, scattering, absorption, attenuation, losses, the signal strength is decreased. Okay, so now that signal strength is increased by using this repeater. Now how many repeaters? That depends upon the distance between the transmitter portion and receiver portion. Okay, so this is nothing but a transmitter section. This block is nothing but a transmitter section. Now this blue color block is nothing but the receiver section, and this red color block is nothing but the channel. Okay, and then I just use the words now. Now see here. Now this is the signal which is a low frequency information signal. This is the signal which is the low frequency. First you note down this, then I will give the names for that. Okay, now see here. Now this is the original information. This is the information which we want to transmit. Now this is the information which is going for modulation. Therefore this is called as modulating signal. Modulating signal. Now this is after modulation. Modulation is done. Therefore this is called as modulated signal. Modulated signal. Now this is the signal which is going to the channel. Therefore this is nothing but transmitted signal. Modulated signal after modulation. Okay, now this is the carrier signal, you know that. Now this is the so output of the transmitter is a modulated signal. Input to the receiver is also the modulated signal. Now this is modulated signal. Now this is the modulated signal. Input to the receiver. This is the modulated signal. Right? Now this is the modulated signal. Then after demodulation, after transducer, and this is your original information signal. Now this is nothing but modulating signal. Modulating signal. Now this is the modulating signal, and this is the message signal. This is the information signal. This is a message signal, modulating signal, information signal. Right? Now similar, this is the original information signal, modulating signal, information signal, and message signal. Now this is the information signal, message signal, modulating signal. Now this is the modulating signal, information signal, message signal. Right? Now see here. Now this is the generalized block diagram of the communication system or any communication system. Now you will take one by one communication system and we want to design. But the designing process should be like this. Okay? Don't deviate. Now first one is, this is the transmitter section. Number one, this total is the transmitter section. Now the second, you just think about the which type of communication channel, transmission medium is the second. Now the third part is nothing but now designing of the receiver is the third part. Okay. The third part is very simple. The third part is just take a U-turn. Exactly what are the process of transmission is doing. Exactly you take a reverse process of the transmission is nothing but the reception. Okay. Now, note down. This is very, very important. The block diagram, and for better understanding of the modulation really practically how exactly the modulation is done, now I will explain with some signals, okay, with some signals concept. And before that, I want to explain a few properties of frequency Fourier transform. Now one of the properties of Fourier transform is called as duality. Very simple. Okay, this is also somewhere we use. Okay, that's what I write. This is the duality property, which is the properties of Fourier transform. A number of properties, but we use one of the property is called as duality property. Very simple property. What is the duality property? Now x of t is a signal. Now in frequency domain, this is capital X of f. Now this is the Fourier transform. Now this is capital X of t. Now small x of t is a signal whose Fourier transform is capital X of f. Now this is capital X of t. Now means not inverse Fourier transform. Inverse Fourier transform is small x of t from small x of capital X of f. But what I am doing now, this is x of t whose Fourier transform is capital X of f. Now I want to take capital X of t, means the signal variation in time. Now whose Fourier transform is definitely the frequency variation. This is nothing but small x of minus f. Small x of minus f. Now see here, very simple concept I am writing here for better understanding. See here. Now this is impulse function, time domain. Okay, impulse function is a rectangular pulse whose pulse width is 0. Now what is its Fourier transform? Its Fourier transform is now Fourier transform of impulse is 1, because the area under the impulse function is always 1. Area under the impulse function is always 1. Bandwidth is infinity. This is Fourier transform of impulse, right? Highest frequency is infinity minus 0, infinity. Now this is the first step is completed in the duality property. What is the second step? Capital X of t. Capital X of t means this is the same signal, but in which domain? Time domain. The same signal which is nothing but now a constant signal. Am I not? The same signal is nothing but a constant signal. Constant signal. Now this is a DC signal, a constant signal, constant or a DC signal, constant signal or a DC signal. Now this is the constant signal or a DC signal whose Fourier transform is a constant signal or a DC signal whose Fourier transform is. Now see here. Now what is the spectrum of a DC signal? What is the spectrum of a constant signal? The spectrum of a constant signal or a DC signal, small x of minus f. A small x of minus f here is nothing but delta of t. Now which is nothing but delta of minus f. So what is delta of minus f? Now t equal to 0, minus f equal to 0. Now delta of minus f, which is nothing but exactly delta of f, because this is a even function. Now, which means that the spectrum of DC signal is an impulse function at f equal to 0. Spectrum of DC signal is an impulse function at f equal to 0. Clear or not? So yeah, I can write like this for better understanding. Now this is the impulse function. This is the impulse function whose Fourier transform is 1. Now in the duality, now 1 is nothing but a spectrum of DC signal. Now whose Fourier transform is delta of minus f, means impulse function at f equals 0, delta of minus f, which is nothing but delta of f itself, delta of minus f, which is nothing but delta of f. Okay, so this is a property of duality which you can easily use, okay, anywhere. Okay, again you can again you can take the Fourier transform of the given signal. That signal is a time variation, you can take directly and apply the duality, and this is the example of the duality function. Now based on this you can easily identify that. Now you tell me, now this is 1's Fourier transform, then what is a phi, a DC signal of 5 volts Fourier transform is, which is nothing but very simple. This is 1 into, therefore this is 5 into delta of minus f, means delta of f. Now 10's Fourier transform is nothing but 10 into delta of f. Now a DC signal of a volts Fourier transform is a into delta of f. Now this is the Fourier transform of a constant signal or a Fourier transform of a DC signal, which is useful. Okay, no doubt. Now the next one is our next property is frequency shifting property, very famous property in the communication system concept. Frequency, listen carefully. Okay, frequency shifting property are also called as, there is another name for this. Why there is another name? But for a signals engineer, only frequency shifting property name is only identified. But as a communication engineer, then we will put another name for this property after understanding this property practically. Okay. Now see here, what is this property saying? This property is saying that x of t's Fourier transform, capital X of f. Now this x of t is multiplied with a carrier. This x of t is multiplied with a carrier. See here, cos 2 pi fct is a carrier signal. Fc, carrier frequency. Cos 2 pi fct is a carrier signal, Fc is a carrier frequency. So now a signal is multiplied with a carrier of frequency Fc, we call it as, okay, x of t is a signal is multiplied with a carrier signal of a carrier frequency Fc. Then you know that what is the Fourier transform of this? X of f minus fc plus x of f plus fc, and the spectral amplitude is decreased by a factor of 2. So this is the frequency is shifting, f is shifting to fc, f is shifting to fc, left side, right side. So now we want to see that property in a graphical method. Okay, now see here, now let us take, I want to take x of t. What is x of t? I just take one signal x of t, I just take it as I just take a rectangular pulse as x of t. Now this is x of t is a rectangular pulse, 0 minus t by 2 plus t by 2. Now this is x of t. Now what is x of t? Fourier transform is capital X of f. Now you know that the Fourier transform of a rectangular pulse is a sinc function. Practical sinc is band limiting signal. Now this is 1 by t this is minus 1 by t. Now this is at, now this is x of f. Now see here, now this is x of t's Fourier transform is x of f. Now this x of t signal is multiplied with cos 2 pi f ct carrier signal. Now this is multiplied with a carrier signal. What is a carrier signal? The carrier signal of peak amplitude is 1. The carrier signal of peak amplitude is 1 because 1 into cos 2 pi f ct. Minimum amplitude is minus 1. You know how to draw the sinusoidal signal. Peak amplitude is 1. Minimum amplitude is minus 1. Peak to peak amplitude is 2. And the frequency is fc. Now this is 1 into cos 2 pi fct. Now what is the signal here? Now any signal multiplied with a carrier. Now what is the resultant signal? Resultant signal also you can see here. Now on one more point also I want to say, any signal multiplied with a sine wave or a cos wave. Any signal multiplied with a sine wave or a cos wave. Now you can write like this. First draw the original signal. What is the original signal? A rectangular pulse. Original signal is a rectangular pulse signal. Then you just take the mirror image of that. Original signal, then mirror image. This is the procedure of any signal multiplied with a sinusoidal signal or a carrier signal. Understand or not? Original signal minus t by 2 to plus t by 2. Then mirror image. This is the mirror image. Now in the common area, frequency of oscillations. In the common area, what is the frequency of oscillations? Fc. Now this is a into 1 plus a into minus 1 minus. Now this is x of t into cos 2 pi fct. X of t into cos 2 pi fct. Now whose Fourier transform is x of t into cos 2 pi fct? Whose Fourier transform is? Now see here, x of t into cos 2 pi fct, whose Fourier transform is x of f minus fc plus x of f plus fc. Means you can easily understand f minus fc equal to 0, which means f equal to plus fc. Plus means right hand side. Okay, remember. Okay. Next, f plus fc equals 0. F plus fc equal to 0. F equal to minus fc. Minus means left hand side. Now see here, which is left hand side, which is right hand side? F. What is f? X of f. Now this is a signal in frequency domain. Now this spectrum, now this x of f is shifted right side. This x of f is shifted left side. Now see, now this 0. Now this 0. Now shifting means only one thing you remember. Shifting means origin is shifted. Now this 0, this origin. Now this 0 is shifted at fc. This 0 is shifted at plus fc. Plus fc means right side. So this 0 is shifted at plus fc. Now therefore, which means that, now see here. Now that 0 is at fc. This is fc plus 1 by t. This is fc minus 1 by t. Now this 0 is at minus fc. This 0 is at minus fc. Now this spectrum is shifted at minus Fc. Now therefore this is minus Fc plus 1 by T. This is minus Fc minus 1 by T. And this spectral amplitude, what is the spectral amplitude? Is decreased by a factor of 2. This spectral amplitude is decreased by a factor of 2. This AT will become AT by 2. Now see here. Now you can easily understand. Then I will just explain the concept of modulation. Now see here. This is the voice information. Let us assume this is the voice information. This is the voice information. Let us assume low frequency information. This is in time domain. What is this? This is also same. Voice information, low frequency in nature, time domain. But when you take the help of carrier, so this is nothing but, when you take the help of carrier, then you are adding the carrier is nothing but, this is modulation, after modulation. Therefore, after modulation, this is called as a modulated signal. This is the modulated signal, but this is the modulated signal in which domain? This is which domain? Time domain. This is the modulated signal. This is the modulated signal in time domain. Now this is also the modulated signal. This is also the modulated signal, but in which domain? This is the modulated signal in frequency domain. This is the modulated signal in frequency domain. This is the modulated signal in time domain. Now what is the modulated signal in frequency domain? The spectrum. See here. This is the low frequency information. Now this is the modulated signal, low frequency information, but this is in frequency domain. When the modulation is completed, after modulation, now this spectrum is shifted right side, this spectrum is shifted left side. Am I right? Not? This spectrum is shifted right side and this spectrum is shifted to left side. Now what we can understand here? When the modulation is done, the low frequency information is transformed to, this 0 is transformed to plus Fc. This 0 is transformed to minus Fc. What is the meaning of that? Now, whenever the modulation is done, earlier I am saying, whenever the modulation is done, this low frequency information region is transformed to high frequency. See here, this low frequency information region is transformed to high frequency. This is the modulation. Now, when we are doing the frequency shifting property, what we can understand? We can understand that, yes, now the modulation is completed. Therefore, this frequency shifting property is also named as modulation property. This is called as frequency shifting property, or this is called as modulation property. This is the frequency shifting property or modulation property. Very simple concept I am saying here. Now, before modulation, this is the low frequency information available as it is. But this low frequency information which is available at high frequency. Let us take, for example, this is 0, this is 1 kHz. Okay, this is 1 kHz. Just let us assume this carrier frequency is 1000 kHz. Okay, now after modulation, what happened? Now this is 1000 kHz. This is 1000 kHz. This is 1001. This is 999. Okay, let us assume this is kilohertz range. Now what happened? What is FH by FL? Now here FH by FL. FH is 1 kilo, by FL is 0. Something by 0, infinity. Now this is before modulation. This is infinite, means wide band signal. This is wide band signal. Now after modulation, FH by FL. What is FH by FL? See here. FH by FL, which means that this is 1001 by FL is 999, means 1001 by 1000 approximately. Now this is nothing but this is approximately 1. This is infinite. This is 1. What is the meaning of that? Now this is nothing but narrow band signal. Now what you can understand, the modulation is the process of converting a wide band signal into a narrow band signal, a wide band region into a narrow band region. This is another advantages of modulation. What is the use of modulation? See here, the before modulation, this is the information. This is the information. After modulation, your information is available as it is, but your information is not at 0. Your information is at a carrier frequency, is at a high frequency. Therefore, this is not only the frequency shifting property. Now, this frequency shifting property, now we also call as modulation property, means we can easily understand how the modulation is done. Whenever the modulation is done, what is the meaning of modulation is done means not the low frequency converted to high frequency. No, the modulation is the process of converting a low frequency region into a high frequency. The modulation is the process of converting a wideband signal FH by FL, infinity wideband signal, into FH by FL is approximately 1, is a narrow band signal. Understand not? The modulation, without modulation you cannot transmit the signal. Now without modulation I cannot fulfill the application of communication. I cannot transmit the information from one point to another point. The basic objective aim of a communication system is to transfer the information from one point to another point, is possible only with the help of modulation. Okay. Now after this I will just have a list of what is the uses of modulation, why we go for modulation, analog communication, digital communication, everywhere you go for communication, use the word modulation. What is the advantages of modulation? Without modulation, what happens? And I will give the list of that. Now, this is one of the advantages of the modulation. Clear or not? And this is the way, graphically you can see. This is the low frequency information. Okay. This is the carrier signal. You are taking help of carrier. And this is after modulation. After modulation, this is a modulated signal. Okay. And we can also say here, this is carrier. This is also the carrier. But this is the carrier before. This is carrier before modulation. This is the carrier signal. This is carrier before modulation. The carrier before modulation, we call it as unmodulated carrier. Unmodulated carrier. This is carrier after modulation. This is called as carrier. This is carrier after modulation, or this is called as modulated carrier. Modulated carrier. Carrier after modulation. Okay. Now this is carrier before modulation. Okay. Note down.